Do you know scientists also fight wars? Yes, when electricity was invented, there was a big fight between Nikola Tesla and Thomas Edison. Now you know Thomas Edison who invented bulb. Okay, he had a muscle power, means he had big amount of money. Okay, he was a wealthy man, but still Nikola Tesla could win this war because of what? We will see how. Okay, so today's topic is how transformer actually work, the science behind electromagnetic field. Okay, so learning objective is master electromagnetic induction. We will see how it happens, then explore mutual inductions, then apply transformer equations we will see, and then compare operational states. Okay, now the time to see the war between Nikola Tesla and Thomas Edison, how they fought. Okay, Faraday's revolutionary discovery. What was it? In 1831, what happened? Michael Faraday discovered that a changing magnetic field induces voltage in a nearby conductor. If there is a conductor and here is coil which will induce the magnetic field. We know that magnetic field will be induced in a coil if you provide the current inside it. And that magnetic field, if it changes, note the word, if it changes, then it will induce the voltage in this current conductor. Okay, that is what you are seeing. The principle is expressed mathematically as EMF, electromagnetic force, that is a voltage. So the equation is EMF is equal to, EMF means voltage, okay, is equal to electromagnetic force. It is called voltage means electromagnetic force. Just remember it. Is equal to N multiplied by d phi divided by dt. So where, what is this electromagnetic force, electromotive force? N is number of turns and d phi divided by dt is rate of change of magnetic flux. See, this discovery became the cornerstone of all transformer operation and sparked AC versus DC war of currents between Edison and Tesla. See what happened when electricity was invented. Tesla had invented AC current, okay, alternating. So it will start from zero, it will go at a peak 90 degree and then again it will come to zero. See, you know, when you are touching AC wire, you feel what happens? You abruptly comes back. This action happens because AC comes to zero, and at that time our body gets time to isolate itself. See, that time muscles are already contracting, trying to pull you out. Okay, so in AC, chances of survival are more because it goes to zero after every 50 cycles or 50 times in a second. Or in case of America, it is 60 hertz. So 60 times in a second it comes to zero, power comes to zero, and then again it mounts to 90 or maximum peak. So this is AC, and DC is at max all the time. So it is not coming at the zero. So only this was the reason Nikola Tesla could win this war. Because if you want to transfer, in last lecture we have seen, if you want to transfer huge amount of power from one location to another location, this thing, transformer, only helps because it will step up the voltage, the current will go down, and we can easily transfer the power by using small conductor. Otherwise, huge current, huge conductors, big conductors. So it is not possible even. Big conductors, like we have seen in 765 kilovolt, that high voltage is transferred from one location to another location. Long distances transfer of power became possible because of this device, transformer, and that's how this guy Nikola Tesla could win the war. Edison tried his best. He had also big network in the cities of DC power, and Nikola Tesla also had a network of power. But these experiments were happening in cities to prove themselves, to prove the buyers, okay, that their power is superior. Okay, but finally, because of this thing, Faraday's helped Nikola Tesla to win this war. Okay, next, mutual inductance, the wireless bridge. What is mutual inductance? Mutual inductance occurs when current flowing through one coil creates magnetic field that induces voltage in second coil without direct electrical contact. We have seen. So this coil induces voltage without any electrical contact. It will induce voltage in other coil because of this flux. This will induce the flux and it will create the voltage in this. The iron core advantage. Transformer use ferromagnetic cores to create. Ferromagnetic means it is a good conductor of magnetic flux. That is called ferromagnetic. Create cores to create a magnetic highway to run the magnetic flux that channels nearly all magnetic field from primary to secondary windings. Entire magnetic field is transferred from primary to secondary. How much? 99%. Coefficient is 99%. So efficiency factor is 97 to 99%. So that efficient. And this becomes making them the most efficient electrical machines ever invented. 99% is like, you cannot imagine that high efficiency. So this is most efficient electrical machines ever invented. Very interesting device, transformer. I like it. It is not boring. Don't think that is boring. Now simply we will see the equations. Turns ratio we have seen already, V1 divided by V2, N1 divided by, so it's directly proportional. Then current ratio, this is inverse. See, I1 divided by I2 is equal to N2. This is inversely proportional. Means if this goes up, this will go down, this goes down, this will go up. Okay. So, see, turns are fixed. So, only current we can change. Okay. So, that we will see how it changes. And so this is inversely proportional. Just remember that current is inversely proportional to turns, but voltage is directly proportional. Then power is equal to P2 plus losses. Losses are negligible. We have seen 97 to 99% efficiency. So this is the power conversion ratio. Now let's say for a transformer with 1000 primary turns and 100 secondary turns. Primary turns 1000 more and second turns are lesser. So it is a step down transformer. It depends on turns, number of turns. If the number of turns are more at primary, then it becomes step down transformer. With 12,000 volt input is 12,000 volt, expect 1200 volt output, because see, this is 10 times more than this, and that is how same this is 10 times more than this. Now with current 5 ampere primary current, only 5 ampere primary, but expect a 50 ampere, 10 times more current in secondary. So it is all because of this turns ratio. Okay, so it is inversely proportional, it increases, and this voltage decreases. So power transfer remains nearly constant because losses are nearly zero.